Welcome to Session 12, Absolute Value Equations. Today you will interpret absolute value as distance, solve two case absolute value equations, and recognize one solution and no solution cases. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. The two arrows have equal length even though they point in opposite directions. When an absolute value expression equals a positive number, the inside expression can be that positive distance or its negative counterpart. This geometry explains why two algebraic cases are required. Use this first move. Isolate the absolute value expression. Then, if it equals a negative number, stop. There is no solution. Worked example, two symmetric solutions. Solve x plus 4 equals 9. Step 1. Write x plus 4 equals 9 or x plus 4 equals minus 9. Step 2. The first gives x equals 5. The second gives x equals minus 13. Step 3. Both values place x exactly 9 units from minus 4. The final answer is x equals 5 minus 13. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Solve 2x plus 1 equals 7. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the modeled solution. The answer is x equals 3 minus 4. Set 2x plus 1 equal to 7 and to minus 7. Verify it against the exact wording before moving on. Session 12 recap. Isolate the absolute value expression. Next, if it equals a negative number, stop. There is no solution. Then, for a positive value, write one positive case and one negative case. Finally, solve and test every candidate in the original equation. A complete solution shows the reasoning, checks the result, and states what the answer means.